Hi, students. Hi. So today's problem is that you just want to extend the capability of Lex. So how to do that? Because Lex is returning a token, but the token consists of several words. Each word is called a Lexeme. So I want to show the slide. No, just hand out how to use Lexeme in Lex. Okay, so let me switch to the screen to your handout. Here it is. So lab 7 using Lexeme. So this is actually jargon. What is an Lexeme? But you know that Lexeme is an actual word of in program text. So you may consider this is a word. And you know that in your program, you have several words, such as int, maybe your word, and 23, maybe your word, and main, maybe your word in your code, assuming C code. And a token is a set of words. For example, for integer, you may want to use a token int, which is a singleton set, or int type may be your token. For 23, you may want to use a token int literal. Int literal was a token, and it is an infinite set. It may contain 23, it may contain 0, it may contain -1, and other things. Okay. For main, you may call this as an identifier. So the identifier is the name of a token, but you know that it is also an infinite set. So in lexical analysis, your lexical analyzer is returning a token. So token is the main concern of it. But after that phase, you know the actual value. Actual value is of interest in the past phase of the lexical analysis. So you are concerning the lexeme. So the lexeme is sometimes called lexical token. So for this case, it can be used interchangeably because it is a singleton set. So sometimes they are using abusively. They abuse the term token for a lexeme, but so some guys prefer lexical tokens as an equivalent to the lexeme. Okay, do you know what I mean, 승희?
네.
So you can tell the difference of lexeme and the token. Okay.
네.
Okay, good. So the string appears in a source code is called the lexical token or lexeme. A token is a kind of lexical token. So this set is not grouped arbitrarily. It is grouped for some purpose. For the integer type, it contains just a single int word. But for integers, it collects some integer numerals. And for identifier, it contains valid identifiers in your code. For example, if your code contains an integer 829, your lexical analyzer may return int literal, enter it as a token ID and as a kind of lexeme of 829. So conceptually, the word 829 is an element of integer literal. So lexical token is represented by YY text. YY text is the name of the lexical token in Flex, also in Lex. So the following code recognizes alphanumeric identifiers and prints each of them as ID with its Lexeme. So you may specify ID. So the intention of this, it is token. And in parentheses, sorry, token, not token. Parentheses means that it will be printed Lexeme. Okay, so as you know, this is a C declaration. Only C declaration is included here. These are the pattern action. So for identifier, for this pattern, you'd like to print a token with its lexeme. For other cases, do nothing. For other words, do nothing. For new line, it is printed on echo for new. That means just print a new line. This is for readability. And as you know, this is a auxiliary function for YY wrap. And this is your main function, but it is treated as an auxiliary function in your code. So let me show you the screen. Okay, so before that, I have to save this and erase this. Okay. So let me show you that the code of YY text in your MinJW terminal. So in this MinJW terminal, you can type the simple.l. Simple.l. Is this new? So let me just type it. So the simple.l, as you know, the lexical analysis has 3 sections. In the first section, it is containing include stdio.h. And in the last section, you have to define YY wrap, return 1, and int main for returning. So let's just make it more readable for just for main. Okay, just for main. And you'd like to make a call the YYLex, the lexical analyzer, and return 0. So in the middle of the section, if you want to just write dot for echo and new line for another echo. So if it is like this, so let me just show you a more advanced makefile. So in your more advanced makefile, you can take a look from your handout. So I'll switch it to your handout. So simple makefile for Flex is that it is using 2 kinds of macros. One is $@, which means the target, and $less than, which means the source. So you may think about that. Your process is here. Your process is here. So let me just draw this with so with this process, thinking about that, your GCC is taking input from your source and make a target. And the rule is for a makefile is that target is dependent to your source. Okay, and you can make the compiling that GCC make an output with a target, and the source may be described here. Okay, so but if the target and source is stored here, then you may use a macro for this. So instead of this source, so you just use this direction. The source is given to this direction. So it is like this. And target is the output, okay, output from your GCC. So you just think about that it is ADA or something, since it is S sign. So you may use a macro S sign here as target. Okay, so the actually this is substitute as that ID num is the output, and this is ID num dot C. Okay, so this is just for sure. It is just a convention. So let me make a new makefile in your MinGW. Save this and remove all the drawing. And in your MinGW, I have to reshare this. Seungyi, why didn't you tell me that? I have to reshare this. So I can make via makefile. So it also already has some of these. Okay, and the flex can be used similarly as an output, but beware that there is no space is allowed between the flag O, minus O, and the target. Okay, so from the simple.l, normally it is generating lex.yy.c, but in your makefile you can specify as a simple.c, so it is the output of your lex. Okay, got it?
Okay.
Okay, Seungyi?
Okay.
So it is much like this. If I want to make it flex minus O, which means that it is output, so I want to simple.c as an output. And as you know, the input program is simple.l. Okay? So the simple.c is created, and then I want to compile it to the output simple from the simple.c. Okay, so it is compiled. So these two procedures can be executed by your makefile. So flex output simple.c. Okay, flex output simple.c. Simple.c is replaced for this, and source simple.l will be replaced here. Okay, so that is the execution of this. How about GCC output is simple, and simple.c is the source. Okay,
Okay.
so after that you can execute simple. So in simple, do you know how? Then it is printed because it echoes every verse. Okay, every characters. So Control D. So if you want to change this simple.l, but you want to just bundle of movement of them, bundle some of the other characters is bundled as echo, but so before that, you may just double echo, okay? And you can just make a bundle of them, then you can make it. And simple, do you know how? Do you know how? So it is printed in double, okay? So if you change the simple.l with these things, it denotes a single line, okay? The whole line, because that denotes any characters except a new line, okay? So the single line is printed twice. So make it simple. Do you know how? Know how? Okay, so this is the output. You know what I mean? So with this setting, you can just make a simple line numbering counter. Okay, because it is essentially, you know that echo is essentially printing printf %s, okay, for YY text. Since YY text is the Lexeme, so it is the same effect. Okay, so make it simple. Do you know? Same effect. Wow, same effect. Okay, so with this setting, you can just declare an integer variable outside of it, which is a line number, which is initialized by 1 or by 0, anything will do. And you'd like to print a line number here, %3D, line number, and the line number is line null, and it is incremented after the execution. So you can just increment after that. Line null is incremented. Okay, this is more clear. So you can make it, and let's just execute simple using simple.m. So you know that every line is numbered with its line number. Okay, so let's go back to the problem. Do you have any questions up here? No questions. Let's go back to the problem that for other characters you do nothing, but for alphabets A to Z and A to Z, the first character should be the normal alphabet, but it is currently small letters only. Okay, so beware, it is currently small numbers only. And 09 is numbers. So in that case, you'd like to printf. This is an identifier with your Lexeme YY text. You just like to print it. For others, is do nothing except a new line. Questions? Sorry. Arrogios, thank you. It is not 0009. Okay, so you know that why it is not working. It's 9. Okay, so it is a very famous character in Korea. So there's a dummy boy whose name is 09, Younggu in Korean. So anyway, so it is so you know that this is another brand of a car, A to Z. Okay, another brand of a small car manufactured by Hyundai. So anyway, so I'd like to make it, but this is actually wrong for that. Okay, make, and you may wonder that simple.l may, oh sorry, simple may execute. Do you know how? Then you may expect 3 words should be identified as an identifier. For all the other things neglected. But you know that everything is neglected. Do you know why? Do you know why? 승희,
모르겠습니다.
do you know why? So let's take a look of the code. Simple.l. So the reason is that it is not matched from top down. So the default is top down. It is in default order. So default matching order is surely top down. But once it is matched in double, something is matched to here and something is matched to here, then Lex selects the maximum length. So you know that if you type do you here, then you know that this is matched. This is not matched, but U is matched for this pattern. Let's call this as the first pattern. And this is the second pattern. And you know that this is matched the first pattern. Okay? But the whole line is matched to the second pattern. So which is the maximum?
두 번째 패턴이 더 깁니다.
Second one. Okay? This is the problem. So it is not using this one, but this one. So let me just check it. So if you change this, where is my cursor? If you change this as a printf with %s, but you just make it with a double underscore before and after, okay, of the %f yy text, okay. Then if the second one is really matched, the whole line is printed with the prefix and suffix with double underscore. Okay, so let's make it. And simple, do you? Yes, this is correct. Okay, so is this right? Yes. So you have to change this simple.l. If you want to just skip others, this will be make as shortened as a single Lexeme. Okay. So let's take a look again. So if you write do you here, this is matched for the second pattern. This is also matched for the second pattern. This is also matched for the second pattern. But this is matched for the first pattern. Okay, so which is the maximum?
첫 번째 패턴에 매치된 거예요.
That's correct. So this will be executed. Okay, so this is what I want. So let me compile it again. Okay, it is occurred to write something. So compile it again. Make it simple. Do you ID is printed. Okay?
네.
That's right. That's right. Then 3 identifiers. T is not matched, that is capital. Okay? but you should include it for the natural identifier. And head is matched, S is matched, right is matched for this pattern. Okay, so it is simple. You can just enter simple.l as your input. Too many identifiers include stdio, h, int, line number, a, z, z0. Wow, striking. Z0 is matched as an identifier because it is truly an identifier of starting from alpha small letters and with alphanumeric trailers. Okay, so you can take a look of this text. Any questions up to here? No questions? Okay, then I'll reshare the handout. Sungyi, do you have any questions?
없습니다.
Arogyo, you have to you have to ask me first. Okay, so I'll tell you after explaining the today's problem. Okay, Arogyo. Okay, so I covered this simple makefile. Okay, and the flex support an option or output, and beware that no space is allowed between the flag and the output file name. And today's problem is that you want to extend the language. In the previous language, it was scheme, which was a very simple language. But today you want to extend it as a C, okay? But without preprocessed directives. But including a single line comment that is included, starting from double slash up to the end of line, except a new line character. New line character should be handled differently. Write a program using flags to recognize the identifiers and the integers of the input program given from the standard input. The token for the identifiers and integers are the ID and int. So token for the identifier is the ID. And for integers is int, respectively. Each of these tokens should be printed with its lexeme enclosed in the pair of parentheses as before. Note that the white spaces, including tabs and new lines, should be preserved for readability. Okay, so you should not skip the white spaces. It is preserved for readability. It is not recognized as a token, but they should be preserved. White spaces should be preserved for readability. And the command should be skipped. Okay. So let's take an example. Let's take a look at an example. For the following input program, for example, you may recognize a token int, and main is another token. YYLX is a token. This should be skipped. Return is a token, and 0 is a token of integer. Okay?
네.
And this is a space. This is a space. Space, 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 space here. These spaces should be preserved. Okay? So you are preserving this space here, space, 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 space here, and single space after that, space, 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 and single space after return. Okay, and for the new line characters, let's make it differently. For new line characters is here, and here, and here, and here. Those should be preserved here. New line, new line, new line, new line. Okay?
네.
And for the identifiers, you are printing them as ID. And for a number, you should print them with int token. Okay? So you can understand the output.
네.
Okay, good. So, but there is some warning. There is some warning. So beware that the pattern of integers. Okay, so the integers can be preceded with a sign. So +1 should be identified as a integer numeral. -10 is also, but however, 10.0 should be identified as two integers. Okay, so into 10, into 0, and dot should be skipped. Okay, it is not a white space or new line. Okay,
네.
okay, good. So based on this experiment, you make a report assignment 8. I will post this while you are doing your laboratory work. You can write a report in Korean. Your report should contain the following materials. The purpose of this report, in short, it is identifying the token with Lexeme, but you should specify it in your words because it is containing for representing some patterns in Lex. Okay, and your whole Flex input file should be posted as a second material, but you should annotate them with some explanations. And you may add some explanations in C syntax because you know that C in your code may be regarded as a code. Okay, so what you have learned and what you have learned in this laboratory. Your program should read from the standard input. Input consists of several lines of C program fragments. The program should print the standard output. The output consists of a sequence of recognized tokens with the lexemes. The program should be submitted to NeoSPAM. Do not forget to select C as the programming language. The following shows two sample input and output. And you know that this is for similar to the previous input. This is for just treating the command, but new line is still printed. Okay, and new line is printed. Even though the new line is invisible here, you have to handle new line mechanically. Okay.
네.
So if you don't have any question, you have about 35 minutes to go. So if you don't have any questions, this is the end of today's lecture. Bye bye. 수고하셨습니다.